two are just like quick examples of what we've already done. Reminding yourself of how to factor. This would be x minus 4 times x minus 4. Your solutions to this would be at x equals 4. It's got a multiplicity of 2. So at 4, I'm going to bounce. The reason why they throw the second one in here is because this is a new type of thing that we have not, what?
Yeah.
What happened?
Why is it literally just exactly what we just did?
Yeah. This next one. Next one is an introduction of something that you might see. I'm probably not going to see it, but you see x to the fourth minus 8x squared plus 16. This is really close to being the same form as x squared minus 8x plus 16, right? And I factored this as x minus 4 times x minus 4. But this one would be x squared minus 4, x squared minus 4. Which ends up giving us x plus 2, x minus 2, x plus 2, x minus 2. Which means I have a solution of negative 2 with a multiplicity of 2 and 2 with a multiplicity of 2. So at negative 2 and at 2, I'm going to bounce. Okay, but that's not really the new stuff. The new stuff is going to come on this next page. But most of the stuff we're going to see. Okay? And that is a situation where I'm not able to factor. I got 4 things I can't factor. Are you joining us? Sweet. So I try the box. X cubed minus 8x squared, 11x, 20. And I realize, okay, well, let's see. Maybe it does work. I got a, maybe a 4, maybe a negative 4. I got an x. Okay, this will be an x squared. Okay, this is, I guess, a 1. But then I think about it. Okay, x squared times x, x cubed. Okay, that works. X squared times 4, is that negative 8x squared? Nope. X times 1, 11x? Nope. Didn't work. You might be thinking, no solutions, but you're wrong. There's something called the rational root theorem, which says, hey, there are lots of possible solutions to things. We're not going to focus on the rational root theorem. It's a little bit tedious and silly. Instead, we are going to use your calculator, which you've been doing already. And you're going to graph an equation that you can't factor. Okay? So I just graphed this equation that I couldn't factor to see, oh, hey, look, I have some zeros here, here, and here. Let's just pick out one of the zeros. Looks like at negative 1. Now to find the 0, just a reminder, you can graph y equals 0 as well. You can do second calc intersect. Enter, enter, enter around the 0 I want to find, and I see negative 1. Okay? Well, if negative 1 is a 0, what does that mean? It means I can write this as x plus 1 times something, right? Since x equals negative 1 is a solution, right? Well, x plus 1 times something equals this. How do I find out what that something is? Math is correct. Something times this, something times x plus 1 gives us this. How do I find that? Somebody is going to get the answer. How about a simpler situation? 3 times something equals 12. How do I get this? You divide by 3, right? Well, if x plus 1 times something gives us x cubed minus 8x squared plus 11x plus 20, what should I do? Thank you, Mr. Steck, for giving us the answer that might seem a little complicated, but it's not. Okay, so we are going to take x plus 1 and divide it by this. Now, do you guys want to divide this way using long division? No, what would you rather do? synthetic division. Let's do synthetic division. -1 goes in the box. That way we don't have to subtract. We can just add. Bring down. Multiply. Add. Multiply. Add. Multiply. Add. Look at that. A remainder of 0. All of a sudden, I say, this is equal to x plus 1 times x squared minus 9x plus 20. This is x plus 1 times x minus 5 times x minus 4. We just found all of my zeros. Now, many of you have already kind of gone the extra step, and many of you have already been graphing the equations without even factoring them, and then looking at the solutions and see that they pass through. And many of you probably already could have figured out that this equation is y plus 1 times y minus 4 times y minus 5. Well, guess what? You're correct. This is the way we kind of can show it, okay? So that is what we are doing, more of the same, only I expect you to be able to synthetically divide so that we can show fully factored forms. But you guys know that you can get to that fully factored form a different way. All right, get out of here. Let's check this one out. X cubed minus 7x squared plus 14x minus 6. I don't know where this one is. I see a nice whole number over there. At 3. Since 3 is a solution, I know I can take x minus 3, divide it out of that. And I can write a factored form, x minus 3 times something gives us 7x squared, x cubed minus 7x squared plus 14x minus 6. Okay? Now, I'm not going to do that. Instead, I'm going to do synthetic division. So I got a positive 3. 1, negative 7, 14, negative 6. Brings down, multiply, add. Multiply, add. Multiply, add. Good. So I get that x minus 3 times x squared minus 4x plus 2 gives us 0. Now I saw that we had 3 zeros, right? My other 2 are going to have to come from here. Now, you can use your calculator to find this, but also you can find it using the quadratic formula because you can't factor, or you can complete the square. So, I don't know, remember how to complete the square? I'll move the number over. I will add something so that I have a complete square. Well, it's going to be x minus 2 squared. I need to add 4 to both sides. Add 4 to both sides. I get x minus 2 squared equals 2. I'll square root. X minus 2 equals plus or minus root 2. I'll add 2. I'll get my zeros are at 3, and then 2 plus root 2, and then 2 minus root 2. All right, so 3 zeros, there they are. And here's the last one. I'll start by graphing. 6x cubed plus 7x squared minus x minus 2 I got a 0 at -1, and it looks like something close to 1. Ooh, -2/3. What's the other one? a half. Ugh. You could try pulling out a half. So I know like x, this is not going to be the correct factored form. Hold on a second. I don't think I grabbed it correctly. No, I did. Let's see. I think I just pulled up the notes, the key, and the key was not telling me that same thing. 6x cubed plus 7x squared minus x minus 2. Oh, there's one at -1. I must have missed it or made some sort of, oh, there's 2. Look at that, 1 and 2. So we had to zoom in to see that our first zero is at -1. That's a little tricky. All right, so since -1 is a solution, that means x plus 1 is a factor. I can divide synthetically. I'm going to use that root. I get 6, 7, -1, -2. Pull that down. I get 6, -6, 1, -1, -2, +2, 0. So I get that this is going to be x plus 1 times 6x squared plus x minus 2. To solve this, I'd try to factor two numbers that multiply to get -12 and add to get 1, +4 and -3. I can factor this. I'm going to use the box to factor 6x squared minus 3x plus 4x minus 2. Since I have the negatives, it's easier if they are in a column. It actually wouldn't matter whichever way you do it. I can pull out a 3x here, a 2x here, a -1 here, and a 2 here. Let's see, that works, that works, that works, that works. Okay, so this becomes x plus 1, 2x minus 1, 3x plus 2. My solutions are -1, 1/2 would work here, and -2/3 would work here. There's 3. That's it.